Every few months, a headline pops up claiming that scientists have created a black hole inside a laboratory. It sounds terrifying. If researchers actually spawned a real gravitational black hole on Earth, its intense pull would make it plummet straight to the center of our planet, devouring rock, magma, and any other matter along the way. Fortunately, Earth is perfectly safe. Nobody is creating world-destroying space-time anomalies in a lab. Instead, physicists are building highly controlled toy systems known as black hole analogues. To understand how the universe works, we have to look at what these surrogates actually are and why scientists go through so much trouble to build them. The story starts with physicist Stephen Hawking, who proposed a famous mathematical theory in 1974. This diagram models what he called Hawking radiation. Hawking predicted that black holes are not completely dark. Instead, quantum fluctuations at their very edge cause them to leak a tiny amount of thermal radiation and slowly glow. The problem is that real cosmic black holes are light years away, and this theoretical glow is far too faint to ever pick up with our telescopes. Since we have no physical way to observe this math at work in deep space, researchers realized they needed to substitute unreachable cosmic variables with controllable earthly ones. The genius of these surrogate models is that scientists don't need the crushing gravity of a collapsing star. They only need to recreate a mathematical point of no return. One way they do this is by building sonic black holes. Researchers take flowing fluids or gases and accelerate them through a highly pressurized tube until they reach supersonic speeds. This diagram maps the acoustic event horizon, a boundary where fluid moves faster than the speed of sound. Sound waves inside this supersonic region get permanently trapped, unable to swim upstream against the stronger current. This acoustic boundary acts exactly like a cosmic event horizon. A black hole for sound functions mathematically as a perfect stand-in for a black hole for light. We can scale this same logic down to the atomic level. Using optical and atomic simulators, researchers cool elements like a Bose-Einstein condensate down to near absolute zero. At this scale, they arrange tightly packed chains of atoms and carefully manipulate how easily individual electrons can hop from one node to the next. By controlling that movement, they engineer a synthetic barrier that forces electrons into a one-way trip, mimicking an event horizon for quantum particles. By freezing matter, dictating particle movement, and engineering tabletop arenas, they simulate the cosmos. You might also encounter older articles discussing an experiment at Stanford's SLA facility. Here, researchers used an ultra-powerful X-ray laser to strip all the electrons out of a single heavy atom. This created a massive positive charge that violently sucked in electrons from the rest of the molecule. The researchers jokingly called it a molecular black hole because of its intense inward pull. But this was purely an electromagnetic effect. It lacked the true mathematical point of no return boundary that defines a real cosmic analog. So what actually happens when we look closely? At the boundary lines of our supercooled atomic chains and supersonic fluids. Inside these carefully constructed environments, energy and quantum mechanics behave exactly as the complex mathematics of general relativity dictate. This side-by-side data comparison shows exactly what researchers were searching for. On the left is Hawking's theoretical mathematical formula, and on the right is the recorded acoustic glow from a synthetic horizon. They match perfectly. Thanks to these tabletop models, scientists can finally observe the physical equivalent of Hawking radiation. This proves a consistent truth about nature. The laws of physics scale across entirely different mediums, whether you are dealing with the fabric of space-time, supercooled atoms, or sound waves. We solved a cosmic mystery without needing to travel light years into the dark to do it. While the viral headlines stretch the truth, the reality is far more impressive. Through sheer ingenuity, scientists brought the untouchable physics of the cosmos down to solid ground.